final session soon, so I would love to have all of you join us back in this session, unlocking new possibilities with stateless architecture in layer 2. So let's welcome Leona Hioki from Intmath. Leona will discuss stateless architectures in layer 2 and how they drive efficiency and scalability. So take it away, Leona.
Thanks so much. Yeah, I'm Leona from Intmax. Intmax is a stateless layer 2, which provides extreme security and privacy at the same time. So, what is statelessness? It's all about posting the minimum data on chain, everything happens off chain. So, data preservation, ZKB computation, everything happens on off chain. So, in a narrow definition in cryptography or financial cryptography, it's like scaling order one. So posting the constant data on chain, no matter how many users come to their network. So this is the definition of statelessness. But what is the most important stuff, and how does it look like? So basically, stateless is quite mysterious stuff. Stateless architecture works like a layer 2 privacy coin, or in sometimes it works like a usual layer 2 or rollup sometimes, and it works like a payment network sometimes. It's quite mysterious, but most important part is like a trade-off between statelessness and the statefulness, right? And what is the trade-off? Stateless architecture has less functionality, and at the same time they have extreme security and privacy. Stateful, it's hard to scale. Like almost 99% or 99.9% of blockchain space are their stateful system. For instance, EVM are compatible chain, and these are a bit hard to scale, but basically they have more and more functionality and convenience, right? So it's well tuned for very kind of specific use cases, and it's all about privacy, right? So what is Intmax? So in short, it's like plasma scalability with strong privacy on the same security assumption of rollups or Ethereum. So it's quite strong features, and we can provide that. So this is a quite simple comparison with the other architecture. So let her introduce Intmax or Plasmanext on the L1 or rollups or Lightning networks. So it's quite simple. And I don't say it's a fair graph. And it's, for example, it doesn't show the privacy stuff here. For example, Lightning Network has strong privacy and instant finality, but I don't describe that. And the L1 rollups has more functionality, but in terms of the quite essential features like UX and the scalability, we need more kind of focus on this triangle. So basically, we can say that in terms of this triangle, Intmax is the best. And what is this triangle? So it's a trilemma we found. It's kind of more academic research on this statelessness. And if we have a stateless scalability or offline safety, like which goes without the node requirements. For example, in Lightning Network, they have a node kind of requirements, right? And to keep it safe, or to keep your assets safe, and keeping eye on the other merchant stuff and something like that. So offline safety, Lightning Network doesn't have that. And the capital efficiency, of course, it's all about there construction where you can spend the all money without depositing before. So in terms of this triangle, it's quite hard, essential, and also it's really important to complete all of these features. So and also we are providing the privacy stuff. The privacy feature is more like flexible to adapt to the legal requirements or social requirements, like stopping their hackers' money or this kind of stuff. And we have that feature as well. So this is a tech overview of Intmax. So, yeah, if we expand these our features to more the other systems like Lightning Network, or yeah, the previous Plasma didn't have an offline safety, for example. And okay, and there used to be discussed kind of impossibility of statelessness. It's well discussed in the academic space, and there to reach out there one conclusion that this kind of red line, it's basically saying that stateless system need to have our local proof, frequent local proof update. And local proof update sounds kind of annoying, but actually we can remove almost all the problem of these kind of annoying UX and or security or let's say communication regarding security, and we can make the problem super minimized and the making local proof updates less critical is our most important update in Intmax. So basically we don't have the stateless impossibility and stateless or the downside in terms of trade-off. So okay, in a nutshell, it's like Plasma, right? Statelessness is like Plasma. Posting the minimum data chain scales everything. And so why do we talk about privacy stuff here? Simply because, yeah, it's very important in the social meaning, and at the same time, of course, it's super important in the market meaning. So basically, in each cycle, for example, the fast bubble and the ICO bubble, DeFi bubble, and the right now 2024, right? And the right now meme coins are quite hard, hot topics are recently, but we ignore that. So each cycle and each bubble had a quite good excitement to have new things, making something less scary. And the first bubble is making self-custody less scary, and the people rush to have that. Before that, people didn't have that so much. And in 2017s, people started to do their own on-chain investment by ICO, and basically it's making on-chain investment, on-chain token transfer less scary for many people. In 2020, DeFi summer started, and before that I was scared of locking many monies on DeFi at the time, on Compound. But after the DeFi summer, almost all people started to lock a low amount of money on the contract. So it's making our DeFi or kind of locked token on-chain less scary. So this time, people are scared of privacy a bit. And so it's a time to make privacy less scary. And okay, scaling privacy. So how to make privacy for people, among people, and including all kind of people, not limited to rich people. So how to make that? So we explain the construction of Intmax. And basically, in Intmax, our stateless architecture provide this communication. So basically, block producer make a market tree from the transaction from users or transactors, and making a market tree and distribute the market proof to the user side. And the user side preserve proof, and they can update that by ZKB off-chain. So everything is off-chain, everything on client side. So it's not even nodes. So basically, we fired nodes, a lot of nodes on the block producer because there's no job left for them. So basically, the ZKB computation, data preservation. This was the biggest role in nodes in ZK rollup architecture, but we don't need them on the user side, client side, do the part. So it's basically up. We can parallelize the computation data preservation up to the number of users. So if there are million people, million level polarization, and if there are billion people, billion level polarization. So there's no bottleneck when even if so many people come to one network. So this is a fundamental different and progress we can have for this. So after this kind of proof distribution communication, there people can prove that there's no history data, no transactions after that. So you can spend the correct money and it prevents the double spend, even if you're kind of didn't preserve your data. So yeah, this communication is meaning that each marker proof itself is UTXO of chain on client side, and you will input this UTXO in your ZKP circuit on your client side. So why is this safe? So we already talked about the double spend prevention, but why balance is enough? Why the transaction is valid? Actually, block producer doesn't have to verify transaction when they make a market tree, and they don't validate. So there's no validator, and there's only tree maker, and client side ZKP verifies the history of UTXO kind of passed by many people are in a long history, right? And we can make this enough balance proof with endless enough balance proof or endless UTXO validity proof with ZKP like this. So it's a recursive ZKP. So the n-2 is proven in n-1, and the n-1 is proven in ZKP n, number n, right? So if you once verify the previous ZKP, you can prove the entire history of ZKP. It's meaning that the entire history of UTXO, right? So no matter how long it takes, you can prove the entire history of UTXO in a constant cost. It's like 1 second or 0.5 seconds on your client side, and it's always a constant cost. So yeah, imagine that it happens in each client side. This endless chain of ZKP happens on client side and each people. So it's million level parallelization, billion level parallelization happened because of this architecture. So yeah, and each transaction can have almost infinite number of transactions. Let's say token transfer. So when you send a transaction, you can include for example, 10K, 10,000 token transfer for many people in one transaction without adding any on-chain cost, because it's just an kind of extension of the market proof, right? So it's so on-chain cost is fixed, 5 bytes per transaction, and you can increase the infinite amount of kind of transfers in that without additional data cost. So, how much time do I have? 7 minutes. Oh, thanks so much. So, okay, why this is good for privacy and why I'm super excited by privacy. We have a tremendous scalability, but still privacy is quite important in this system. So to scale privacy, there's two aspects, kind of technical scalability and the social scalability of privacy, right? So what about the social scalability? So of course, kind of UX, privacy ruins UX sometimes, and the legitimacy is like social requirements, right? I don't like to talk about this so much, but it's quite requested, so I need to talk. And yeah, so we already talked about the technical scalability of privacy, so what about social? So TPS on the meta privacy is quite hard, hot topic or in privacy, in my opinion. So, for example, if you use Tornado Cache, almost 100% you are a privacy user, right? So, because Tornado Cache is like, very super focused on privacy, and maybe there's no usage or no auto privacy. So, if you use Tornado Cache, and if you use Monero, yeah, I like both of them, but if you use that, your address will be marked as your account will be marked as a privacy user, right? So what about Lightning Network, for example? Lightning Network have a kind of advanced privacy in this perspective because so many users are using Lightning Network for just scalability, right? And so using the fact that using Lightning Network doesn't mean that you're a privacy user. So you can mix up your user type information as well. So basically, it means that you don't have to scared of your address is marked or this kind of stuff. So basically, mixing the type of kind of many types of people in one protocol is quite important. So in my opinion, the privacy protocol need to have kind of the other purposes at the same time. So that's the reason why TPS and the ultra scalability is quite important for privacy. Normal privacy is like making privacy among citizens. So you don't have to be a kind of monstrous privacy user or monstrous privacy tech bro to have privacy. And it's quite important simply because it's if we can make this just for manners, just like a manner, like a knocking door or you don't open the the others are no room and these kind of stuff. If we can make her just normal privacy, we can make her quite meta privacy, as I mentioned in the last slide. So privacy should be more for normal people, not for the privacy tech pro. This is kind of happening in this space right now. And for example, privacy pool, and which is published by the Amin Soleimani and Vitalik. These people published paper, and it's actually implemented in Railgun, and they can prove that your fund is innocent with ZKP, and it's super cool. It's still quite neutral and cryptographic, but they can prove that by specifying their anonymity set by yourself. And also unstoppability we can provide, because in this system, the block producer is all about just making tree and the poster marker root on chain. So, and there's no verification or the kind of calculation costs. So it's super cheap to be a block producer. So basically, you can imagine that even Windows XP can be a ZKP, a ZK rollup hard node operator or kind of block producer. So it's quite important to have unstoppability like this. Okay, so that's it. And so at the last, I want to introduce privacy mining, what we are doing. Privacy mining is a kind of token mining generation. Right now it's a point system, but it's basically automatically mined, so it's not like a usual point system. So it's kind of untransferable token right now. And you can be a shareholders of this very unique tech, Stateless architecture project. Right now. Right now we already started the privacy mining, and if you Google privacy mining or search privacy mining on Twitter, you can find that the Intmax account are talking about that, and it's making a great anonymity set together just joining the anonymity set, and it's automatically rewarded just coming in to the protocol and going out. No, you can do that instant actually, and so privacy mining is quite important in terms of projects. So yeah, please join this. Please search it on Twitter or somewhere. Yeah, thanks so much.
Thank you very much, Leona. In next, big round of applause to Leona, please.